So today we're going to continue with section 5. Today we're going to be adding and subtracting rational expressions. So again, this is just a little explanation of what you need to do when you add and subtract fractions or rational expressions. We need to find a common denominator. So when we go to find a common denominator, let me just first review some fourth grade stuff here. So for example, if I had 1/2 plus 1/3, anybody know what the common denominator is going to be here? 6. Good. So when we add and subtract fractions, we need to find a common denominator first. So if you remember, whatever we did to make the denominator a 6, we also have to do to the numerator. So for the first fraction, I had to times the top and the bottom by 3. So my new fraction for 1/2 becomes 3/6. My new fraction for 1/3, I'm going to multiply the top and the bottom by 2. Now that I have a common denominator, all I do is go back and add the numerators, and I keep the denominator. Everybody remember how to do this? All right, let's try another one. Let's say I'm asking you to subtract this time. 1/4 minus 1/8. What is going to be my common denominator here? It's going to be 8. So the 1/8 stays. What did I have to do to the 4 to make it become an 8? Multiply by 2. Whatever you did to the denominator, you do to the numerator. Now that I have a common denominator, I subtract the numerator, and there's my answer. So we're going to apply these same skills that we did way back in 4th grade, but our fractions or our rational expressions are going to get a little bit more complicated. This next slide is just an addition example from your textbook. Again, all you're going to do is add the numerators and keep the denominators. But notice here, they're not common. So I'm going to do some more examples of this, but I just wanted to give you an example from the textbook, how it walks you through. The next slide is also a subtraction example from the textbook. Again, it walks you through step by step. And in blue, it has the description. This is a big caution here when we get to the subtraction fractions. Remember that if you're subtracting more than one term, we need to distribute that negative sign. And we're going to see that in example 2. So let's try a few examples. So here's my first example. Notice I already have a common denominator. So all I need to do here is go back and add my numerators. So really all I'm going to do is 5 plus 9, and the denominator is 3x. So 5 plus 9 is 14, and I leave the 3x in the denominator. If I could simplify, I would, but I can't simplify anything, so I'm finished. The next one is a subtraction problem. Again, this is where my caution is going to come in. So when I go to subtract this, it's already got a common denominator. So what I'm doing here really is x minus 3 minus 3x minus 5. So my caution was this subtraction sign needs to get distributed to all of this. So sort of do like your keep flip change, or multiply everything in here by -1. So x minus 3 minus 3x plus 5. All I did was distribute the subtraction sign. Keep the same denominator. Now I go back and simplify my numerator. I'm going to add my x's and add my constants. So x minus 3x gives me -2x, and -3 plus 5 gives me 2, and it still has the denominator of 4. Now, I need to simplify this. So I can factor a GCF out. I could factor out a GCF of 2 and get -x plus 1 over 4. And then I can simplify. 1, 2, final answer, -x plus 1 over 2. Now, we could have also, right here, pulled a negative 2 GCF out. If you did that, you got that. You're still going to simplify, but then you have a negative 1, x minus 1 over 2, and then you could distribute it, and then it looks the same. So either answer. Either pulling out a negative 2 GCF or a positive 2 GCF. Either way. Try another one. Again, I already have a common denominator, so all I need to do is add the numerators. So 2 plus 5 over x plus 3. 2 plus 5 is 7 over x plus 3. And I'm done. The next example, we need to first look to see, does it have a common denominator? Looks similar, but they're not exactly the same. In order to get this one to look like this one, I am going to multiply the second fraction by negative 1. So if I take 5d over d minus c, to make it have a common denominator, I'm going to multiply the numerator and the denominator by negative 1, which would now give me negative 5d over negative d plus c. And then if I flip that around, I can make it look like c minus d. So let me rewrite the first fraction. My newly transformed fraction with the common denominator. And now I can add the numerators. 5c minus 5d over c minus d. Again, remember in the R5a section, we need to simplify this fraction. So I need to reduce it. I can factor out a GCF of 5 out of the numerator. And now the c minus d's cancel. Final answer, 5. What's my common denominator? You need to represent everything. So notice the first fraction has a 5 and an x plus 1. The second fraction only has the x plus 1. My common denominator is going to be what I underlined in red. It's going to be the 5 times the x plus 1. So my first fraction's good to go. It has everything it needs. But my second fraction is lacking the 5. So I'm going to multiply the numerator and the denominator by the 5. So now 5 times x plus 1, and then 5 times the x for the numerator. Now that the denominators are the same, I add the numerators. 4 times 5x, or 4 plus 5x over 5 times x plus 1. And I'm done. If you prefer to write it as 5x plus 4, you can do that also. You do not need to distribute the denominator. So either answer here is acceptable. For number 6, yes?
Can't you simplify that more?
What do we want to simplify?
The 5x.
Okay, so remember that this, let me see if I can erase here. Remember the fraction bar is the grouping symbol. So I can't simplify the 5x and the 5 because I need to find something that looks identical to this in the denominator. So I can't cross off the 5's because it's attached. Does that make sense? Okay. Let's try another one. What's my common denominator on number 6?
12.
Good. Okay, some people might be tempted to multiply and get 24, but it's going to be 12. So my common denominator here is 12. What did I multiply 4 by to make it become a 12? Good. Whatever you do to the bottom, you do to the top. What did I multiply the second fraction by to make it a 12? What did I multiply 6 by? Good. Whatever you do to the bottom, you do to the top. Everybody with me on that? Okay, so next what we're going to do is distribute. So 3 times 1, 3 times 2x. Over here, 2 times 1, 2 times 2x. All over 12. I now am going to combine my like terms. So I have a 3 and a 2 that I can add. And then I can also add the 6x and the 4x. So I get 10x plus 5 over 12. I can actually pull out a GCF of 5 out of the numerator. And I'm left with 2x plus 1 over 12. Now, in this particular problem, it doesn't help me cancel anything. So I would be okay with you leaving it like the answer I just boxed in yellow. If you would like to go ahead and factor out the GCF, just to make sure that you're double checking that nothing cancels. So you only need to factor when it helps you cancel or simplify. Try the next one. Common denominator here. It's a subtraction problem. Remember, when we are finding a common denominator, everything needs to be represented. So I need to have in my common denominator the x minus 1 and the x. Some students are tempted to just put in minus 1 here, minus 1 here. Doesn't work that way. So my common denominator is a combination of them being multiplied. So my common denominator is going to be x times x minus 1. So we can see the first fraction is missing the x. The second fraction is missing the x minus 1. So the first fraction, the numerator becomes x. The second fraction, it becomes x minus 1. Again, remember, when you have subtraction problems, this subtraction sign needs to distribute to all the terms in that numerator. So this problem becomes x minus x plus 1 over x times x minus 1. I'm going to add my like terms in the numerator. X minus x is 0. And I'm left with 1 over x times x minus 1. And I'm done. For number 8, again, the common denominator here is going to be all of this. So my common denominator is going to be x minus 3 times x plus 3. You need to represent everything. So the first fraction is missing the x plus 3. Whatever you do to the denominator, you do to the numerator. So this will become 2 times x plus 3. And over here, this one's missing the x minus 3. So 4 times x minus 3. Now, common mistakes that students make, they think they can cancel before they distribute and combine like terms. You must distribute first. Don't think you can cancel the x plus 3 and the x minus 3. It's just going to go back to your same problem. So we need to distribute 2x plus 6. I'll distribute the blue. for x minus 12, and then it's on top of x minus 3, x plus 3. I'm now going to add my like terms. 2x plus 4x is 6x, and 6 minus 12 is negative 6. X plus 3, x minus 3. Now, I'll go ahead and try to pull a GCF out of the top. It'll be a 6, but notice it doesn't do anything for me. I can't cancel anything, so you can leave your answer either way. So you can either leave it like this, because pulling the GCF didn't get me anything to cancel, or leave it like this. Either way. Again, the GCF has to, or the common denominator has to be, the LCM has to be a representation of everything. So my common denominator here is going to be a times a plus 1. So the first fraction is missing the a plus 1. So a plus 1 times a plus 1. And this one is only missing the a. Again, don't look for things to cancel until you combine like terms. So for this one, I do need to FOIL this because I need to combine it with this, subtracting this a squared. So I'm going to FOIL this. And this is going to turn into a squared plus 2a plus 1. And then I still have the minus a squared. And then it's all over the denominator, which is a times a plus 1. I now can combine my like terms. Notice this cancels. So now I'm left with 2a plus 1 over a times a plus 1. Nothing else simplifies, so I'm done. For number 10, if there's a trinomial or a difference of two squares or a difference of two cubes or sum of two cubes, you need to factor it first. So I'm going to change this denominator into x plus 1 and x minus 1. Now again, remember your denominator needs to represent everything. So the common denominator is going to be x plus 1 and x minus 1. The first fraction has everything it needs, but the second fraction is missing the x minus 1. So the new numerator here is 4 times x minus 1. Again, you must distribute and combine like terms before you can simplify anything. So x plus 4x minus 4 over x plus 1, x minus 1. You're going to combine these two like terms, and this will give you 5x minus 4 over x plus 1, x minus 1. And you're done. You don't need to FOIL it back. You may see it represented as FOILed back. However, you can leave it like this. If you FOIL that denominator, it turns into that. These. All right, number 11. Again, they look the same, but again, remember, they're backwards. So to change this fraction, I'm going to multiply the numerator and the denominator by -1. So then this will become -1. And then when I multiply this, it becomes -1 plus 2m. And then I can flip it around. So now it looks the same. So now I have 2m over 2m minus 1 plus -1 over 2m minus 1. Again, group your numerator. And notice I get the same thing over the same thing. Anything divided by itself is equal to 1. The next example, it's a little bit long. I need to factor this thing and make this d plus 1, d minus 1. Okay, so for number 12, we do need to still find a common denominator. So we need to factor these denominators so we can already see what we're working with. So again, remember, when we find a common denominator, we need to represent everything that's here. So in my denominator, I'm going to need to include a d plus 1, a d minus 1, and the 2. So for my common denominator here, it's going to be 2 times d plus 1 times d minus 1. And then I'm going to go back and see what each fraction is missing. So for my first fraction, we can see that it's missing the 2. So I'm going to multiply the top and the bottom both by 2. And now it's got the missing piece. For the second fraction, it's missing the d minus 1. So again, remember, whatever you are going to add to the bottom is going to be, you're going to also multiply to the top. So the numerator here will be d minus 1 times 3. So again, we're going to need to distribute. So here, my new numerator is going to be 2 times d plus 2, and then minus 3 times d minus 1. The denominator is still here the same. It's 2 times d plus 1 and d minus 1. So I'm not going to simplify anything. I need to distribute first. So this becomes 2d plus 4. The red becomes negative 3d plus 3. Still same denominator. I'm going to combine my like terms. So I can combine the d's and I can combine the constants. So final answer here, after I combine the like terms, I'll get 2d minus 3d will give me negative d, and 4 plus 3 is 7. So 7 minus d over 2 times d plus 1, d minus 1. If you'd rather write it as negative d plus 7, that is also an acceptable answer. So either answer here is acceptable. So now, one more example. So again, we need to make sure we're representing everything. We're going to need to factor the denominator first. So common denominator here is going to, well, the factored form of the first fraction, I can factor out a GCF of b. Over here, I can factor out a GCF of a. Now, they're looking the same, but not really. If I would have pulled out a negative a here, then it's going to look, it'll look better. So let's go ahead and pull out a negative a GCF. So negative a, this now becomes negative b plus a. And then if I flip it around, it looks at least the parenthesis part. So now my common denominator again is going to have everything. It's going to have a b, it's going to have an a minus b, it's going to have a negative a, and then this is already in common in both. So the first fraction is missing the negative a. And the second fraction is going to be missing the b. So let's go ahead and rewrite this. So right now I'm at a over b times a minus b plus b over negative a minus b. So again, this one is going to get multiplied by a negative a. Let's move the negative sign to the top. And now let's just multiply this fraction by an a and this fraction by a b. So this will become a squared. The denominator here is ab times a minus b. Over here becomes a negative b squared over ab a minus b. And again, add the numerators, so a squared minus b squared over ab a minus b. I can factor the numerator. It's the difference of two squares. So a plus b, a minus b over ab a minus b. This will simplify. And my final answer is a plus b over a times b. And that is your fully simplified addition problem. So your homework for this lesson is page 54. It's numbers 39 through 57 odd, and this homework is due on Monday. So tomorrow we can work on some more examples to make sure that you're understanding the adding and subtracting of rational expressions.